Hello everyone, welcome to today's lecture. So in this lecture we're going to be looking at limits. So I'll start first by introducing how you solve or how you calculate limits, and then we'll start with the simplest question, and then we'll also look at how you calculate limits when a certain variable is approaching infinity. Then apart from that, I think we'll also discuss how to find the horizontal asymptote, the vertical asymptote, and the slant asymptote. So let's quickly begin. Okay, so we have this question here which says evaluate the following limits. So what we should understand is that if you've been given any function f of x, and then they tell you to say evaluate the limit of f of x as x is approaching a certain constant c, the answer is always a constant this side. If this is a number, if this is a constant. So what this means, if for instance the function f of x is x squared plus 2, this means that to find the limit of f of x as x is approaching c, you have to replace. So I'm trying to say to find the limit of f of x as x is approaching c, you have to replace c while there is x there, so that you have c squared plus 2. So this is how you find the solution to limits. So let's quickly do these questions. Alright, so the first one there, we have evaluate the following limits. So to evaluate the first question there, I'm just going to replace 5 where there is x. So saying the limit of 2x squared minus 3x plus 4 as x is approaching 5 is simply just found by replacing 5 where there is x. Then when you simplify this, the first part here will give us 2 times 25 minus 15 plus 4. Then this first part will give us 50 minus 15 plus 4. So 50 minus 15, this will give us 35 plus 4. So when you add this, you're getting 39. Okay. So this is how you solve such a limit. Let's quickly do the next one. So this one is also found by replacing negative 2 where there's x. So we have the limit of x to the power 3 plus 2x squared plus 4. Then everything over 5 minus 3x as x is approaching negative 2. So this one is found by replacing negative 2 where there's x there. So we're going to put negative 2 there, then plus 2, then negative 2 squared, then plus 4. Then everything over 5 minus 3, negative 2 there. So what you just need is to simplify this expression. The first part will give you negative 8. The second part will give you, this will give you 8 as well, because negative 2 squared is 4 times 2. So give us positive 8, then we have positive 4 this side. Then everything divided by, this is 5 minus, so negative times negative 2 there, negative 3 times negative 2 get 6. So this will be 5 plus 6, that will give us 11. So when you simplify this, you're getting 4 over 11, because 8 and 8 will give you a 0. Same applies to this one. So the limit of the square root of u to the power 4 plus 3u plus 6 as u approaches negative 2, this is just simply equal to, you just replace negative 2 while there is u there. and then you get your solution. So you have negative 2 to the power 4 plus 3, we put negative 2 there, plus 6. So when you simplify this, you get the square root of, so this first part will give you 16, and then you have minus 6 plus 6. So this and that will give you a 0. You just remain with the square root of 16, which is just 4. Let us look at this one. So these are simple and straightforward questions, and I believe it's not something that we should take a lot of time to solve. So that question there is a little bit tricky, because when you replace negative 2 in the denominator, you get undefined as your answer. So if you try to put 2 while there is x there, you'll find that you're going to have 2 minus 2, which will give you 0. And then any number there divided by 0 down, it means that it's undefined. So now, if it's undefined, how can you simplify that? So in most cases, when you're dealing with limits, always avoid to find the answer which is undefined, unless otherwise when the limit does not exist. So let us try to simplify this expression. So simplifying that expression, we first have to factorize the numerator. So the numerator is simply just x squared plus x minus 6. So we find the product. The product is found by multiplying the coefficient of x squared and the constant, which will give us negative 6. Then the sum is equal to positive 1, which is just the coefficient of x. Then the factors are, so the factors of this quadratic expression are simply just negative 2 and 3. So we have negative 2 and 3. When you add these two numbers, you have to get a sum, and then when you multiply them, you get the product. So we replace them where there is a sum there. So we have x squared, negative 2x, positive 3x, then we have minus 6. Then you factorize. When you factorize, you're going to have x outside, and then you have x minus 2 there. Then you say plus, the factor here is 3, and then we have x minus 2 there in brackets. So we pick the common factor there, we write it there, then we have x plus 3. So this is what we're going to replace on the numerator there. On this part, the numerator, we're going to replace with x minus 2 and x plus 3. We see what we're going to have. So the limit will become, while there is x squared plus x minus 6, we put x minus 2 times x plus 3. Then the denominator is simply just x minus 2, which is there, as x is approaching 2. So you see that this and that will cancel, and therefore you just remain with the limit as x approaches 2 of x plus 3. So what this means is that while there is x there, you have to replace with 2. So when you replace 2 there, you're going to have 2 plus 3. Then 2 plus 3, the answer will simply just be 5. So that is how you find such a limit. So the same applies to part E, which is the next question. You always have to make sure that you simplify the expression so that the answer that you get will not be undefined. So let's quickly do that. So I'm going to solve this one. I'm going to solve this one. So solving this one, on top there we have the limit of x minus 5, then everything divided by x squared minus 25 as x approaches 5. When you replace 5 where there's x there, you have 25 minus 25, which will simply just give you a 0. Then any number divided by 0, the answer will be undefined. The answer will be undefined. So let us now see how best we can solve this. So when you look at the denominator, this is the difference of two squares. which implies that we can write it as x plus 5 and x minus 5. So you see that this x minus 5 on top, this x minus 5 will cancel with that x minus 5, meaning you just remain with the limit as x approaches 5 of 1 over x plus 5. So we just replace 5 what is x, so we have 1 over 5 plus 5, which is just 1 over 10. Okay, so this is the solution to this expression. Let us now look at this one, which is a problem to most of us. So let us see how we solve such a question. Because you know that when you replace 7 on the denominator there, you're going to have the solution becoming undefined. So when you replace 7 on the denominator, you find to say the denominator there will be 0, hence the solution will be undefined. And that's the case we don't want in limits. That's the case we're trying to avoid. So how do we solve such a question? You remember the principle of conjugates. So let me first simplify this expression before I even replace 7 in there. So I have this expression, which is x plus 2 then plus 3 over 7 over x minus 7. So I'm going to multiply everything, both the numerator and the denominator, by the conjugate of the numerator. So the conjugate of the numerator is the root of x plus 2. Then while there's a plus here, I'm going to put a minus. The root of x plus 2. While there's a plus there, I'm putting a minus. So ensure that what you've put on top there is exactly the same as what you've put down. So when you simplify this expression, we're going to have this expression here multiplied by this expression. Since there's a minus there and there's a plus there and everything else is the same, it's just the same as having x plus y times x minus y. When you check, what is here is exactly the same as what is there, except that there's a plus there, then there's a minus there. So this is a difference of two squares, which can be written as x squared minus y squared. This also applies to this expression, so meaning you can also write this expression as the root of x plus 2 squared minus 3 squared. And then everything down, we have x minus 7 multiplying with this expression there, which is the root of x plus 2 minus 3. So this first part here, that square and the square root there can cancel, meaning we just remain with x plus 2. Then we say minus the 3 squared there will give you a 9. Then everything down here we'll have x minus 7. Then we still have this expression, which is the root of x plus 2 then minus 3. So let's proceed simplifying. So when you simplify the numerator there, we're going to have x 2 minus 9, the answer will be negative 7. And then down there we'll still have x minus 7 multiplying everything with the root of x plus 2 minus 3. So you can see that this and that will cancel. We'll just remain with 1 over the root of 1 over the root of x plus 2, then we say minus 3. So now what we just need to do here is to replace now the value of x, what is x. So now let us find the limit as x approaches 7 of this expression, because we know that this expression is also the same as that expression there. So say 1 over the root of x plus 2 minus 3. This is what we have. So we replace 7 where there is x, so meaning we have something like 1 over the root of, so 1 over the root of what is x there, I'm putting 7, plus 2, we say minus 3. So this will be 1 over 7 plus 2, that will be 9. So this will be the square root of 9 minus 3, which is just 1 over 3 minus 3. So this will also give us a 0. So this implies that the limit of this expression does not exist, because it's still giving us undefined even after simplifying the expression. If not that, it means that they made a mistake maybe the time they were preparing the question. Okay, so let's quickly move on to this expression. So for this one, let's try to replace a negative 4 with this x there. So when you replace negative 4 there, you're going to have so when you replace negative 4 in the denominator, you find that 4 squared, that will give you 16. 16 minus 12 will give you 16 minus 12 will give you 4. 4 minus 4, that will be a 0. So what you just need to do is to simplify the numerator. You factorize the numerator and also factorize the denominator. And then after factorizing the numerator and the denominator, you find certain things that are going to cancel, and then after simplifying the whole expression, this expression here, while there is x, you come and replace with negative 4. So what I'm trying to say is this. Okay. Okay, so what I'm trying to say is that you factorize the numerator, you have 2 factors on the numerator, then also the denominator, you have 2 factors. So you discover that one factor is going to cancel with one factor down there. Then whatever you're going to remain with this side, you replace negative 4 with this x and find the answer. So let us also look at this expression here. So for this expression, this one is similar to this one. So what that means is that you just have to factorize the numerator, and then after factorizing the numerator, you find that this x minus 2 come and cancel with one of the factors on top, like what happened here. Then afterwards, replace the value of 2 while there's going to be x in this expression. So whatever we did on this one is exactly what you're supposed to do on this question. So I'm going to do it for the sake of understanding, because this one failed, so I'm going to do this one. Okay, so this one, let us first start by factorizing this expression. So we have the square root of 1 plus h minus 1, then everything over h. So we're going to multiply both the numerator and the denominator by the conjugate of the numerator. So the conjugate of the numerator will be the square root of 1 plus h. Then while there is a minus there, we will put a plus. Then we say everything divided by this the same conjugate here, which is the root of 1 plus h, then plus 1. So after simplifying that, remember we have the same things in both brackets, except that there is a difference in signs between the first one here and the second. We have a minus there, we have a plus there, which implies that this is the difference of 2 squares. So can write it like that. Everything divided by h times the root of 1 plus h plus 1. So now when you simplify the first part here, you're going to have 1 plus h, then simplify 1 squared will also give you 1, then everything divided by h times the root of 1 plus h, then plus 1. So we can simplify this further. You see that 1 and 1 there, 1 minus 1 will give you a 0, so just remain with h on top. Then down there you have h multiplied by the root of 1 plus h plus 1. So this h and that h will cancel. We just remain with 1 over the root of 1 plus h plus 1. And this is going to be and this is what we're going to use to find the limit. So now we're going to say we find the limit as h approaches what? 0 of 1 over the root of 1 plus h plus 1. So this will simply just be equal to, you just replace 0 while there's h there, and this will be, when you put 0 while there's h there, you're going to have 1 over the root of 1 plus 0 then plus 1. So you just remain with 1, the square root of 1, the square root of 1 plus 1, which is just 1 over 1 plus 1. The solution is simply just 1 over 2. So that is how simple limits are. This is how you simplify that kind of expression. So we also move on to this one, but this one I believe is straightforward. So this one is also straightforward. I'll just simplify it and then you have to find the limit. Or see, maybe I can do everything. Okay, so for this one, it's just a matter of simplifying it as well. So when you simplify this expression, you can write it as x squared squared minus 4 squared over x minus 2. So this can be simplified further because this is a difference of two squares, which will be x squared plus 4 x squared minus 4, and everything divided by x minus 2. So when you simplify this further, this part can also be simplified because this is a difference of two squares. Remember, x squared minus 4 can also be written as x squared minus 2 squared. You see that we have two numbers which have been squared subtracting themselves. Hence, this 4 can also be written as 2 squared. So we can also further simplify this as x squared plus 4. Then in these brackets we're going to have x minus 2 and x plus 2. Then everything divided by x minus 2. So you can see that this and that will cancel. So this limit is just going to be the limit of x squared plus 4 multiplied by x plus 2 as x approaches what? 2. So meaning you just put 2 while there's x there. So when you put 2 while there's x, you're going to have 2 squared plus 4. And then we multiply everything by 2 there and say 2 plus 2. So you're going to have 4 plus 4 there, of course. 4 plus 4 and 2 plus 2 will give you 4 as well. So 4 plus 4, this will be 8, then 8 times 4. So this will give you 32 as the answer. So even this one is just a matter of simplifying it. This one is just a matter of simplifying it. Even this one. So when you look at these questions, this one and this one, the conjugate we're finding was for the numerator. But in this case, we're going to find the conjugate of the denominator. Yes. So in that case, we'll have to find the conjugate of the denominator. Okay, so let me do it step by step. So this one is just a matter of simplifying it. You find the common denominator and then simplify the whole expression. Even this one, you just simplify it. It's also straightforward. So let's look at this one, which is a bit complicated because when you put 0 there, you're going to have a 0 as a denominator, which is undefined. So we find the conjugate of the denominator. So for these questions which I've left, you can solve them at your own time and then see if you are going to get them correct or wrong. If you are not sure about your solution, you can send it over to my WhatsApp line, which is in the description, and then I'll check for you whether you're correct or wrong. So the conjugate of the denominator will be the square root of 1 plus 3x, then you say plus 1, then you say the square root of 1 plus 3x, and you say plus 1. So when you multiply everything there, we're going to have x times the square root of 1 plus 3x then plus 1, and then everything divided by, when you multiply this and that, since everything is the same, the only difference is the minus, the minus here and the plus there, meaning it's also the difference of two squares. We're going to say the root of 1 plus 3x and then squared minus 1 squared. So the numerator there will be x multiplying 1 plus 3x, then say plus 1. Then everything down will give you 1 plus 3x, then minus 1. So you discover that if you simplify this expression, this 1 and this negative 1 will give you a 0. So on the denominator there will just remain with 3x. So the numerator will still be the same. Then everything divided by 3x down. So that and that will go. So you just remain with the root of 1 plus 3x, then plus 1, then everything over 3. So now to find the limit, we're just going to say the limit as x approaches 0 of this expression here, which is the root of 1 plus 3x, then plus 1, everything over 3. So you replace 0 there's x there, so you're going to have the root of 1 plus 3 times 0, then plus 1, everything over 3. So 3 times 0, the answer is 0. So the square root of 1 is 1. 1 plus 1, you get, so 1 plus 1, you get, 1 plus 1 will give you 2, and then the denominator there will just be 3. So this is exactly what you get as your solution. Yeah, that's what you get as your solution for that expression. So for the remaining two questions which I've left, you can solve them and see if you are getting the correct answers, and check yourself if you've gotten the concept on how you simplify algebraic expressions, and also how to solve limits. So basically, when you're dealing with limits, it's not just a matter of replacing. You should know what it means when you're dealing with limits. When you have, for instance, this expression here, this, when finding the limit of this, you say the limit of each independent term there. So you can say, let me first write everything, the limit of 2x squared minus 3x plus 4 as x is approaching 5. So this one is supposed to be written, if you're just following the right procedure, it's supposed to be written as the limit of 2x squared as x is approaching 5 minus the limit of 3x as x is approaching 5. You just write the limit of as x is approaching 5 of each independent there in the expression, in each independent term in the expression. So we have of each term rather as x is approaching 5. And then you begin to work them out one by one. So you say 2 times the limit of x squared as x is approaching 5 minus 3 the limit of x as x is approaching 5 plus the limit of any constant when x is approaching any number is simply just a constant. So the limit of x squared when x is approaching 5 is simply just found by replacing 5 where there is x. So I'm just showing you the right steps to follow, but even just replacing direct is a correct way of doing it, but there are just some lecturers who would want you to show all the steps. So you put it like that, you put 5 there while there's x, then you say plus 4. So this will give you, oh rather this one is supposed to be squared, so this will give you 2 times 25 minus 15 plus 4, which will therefore give you 50 minus 15 plus 4, which will finally give you 39 as the answer. So that is how you follow the steps to solve limits. Okay, so let's quickly move on to the next question.